Let's take a look at adding and subtracting fractions. All right, so I've pulled some problems off of the practice part of the software. And the key thing to remember when you're adding and subtracting fractions is that you have to have a common denominator for that to work. All right, so sometimes you're going to get lucky, like on this first one, and the denominators are already the same. So that makes life easy. All you're going to do is go ahead and do the operation, but you do it with the numerators. So I'm going to do a 12 minus 5, so that'll get me a 7. And the denominator always just stays the same, so it'll just be 7/19. 12/19 minus 5/19 is 7/19. Okay, now you won't always be that lucky to have the common denominator, so let's work on how do you get it to be the same. So in this next example, I have a 6 and an 18. So what you do is you look at those two numbers and you try to figure out what is the number that they both will go into. Okay, well they both go into 18. So that makes life good here. I already have an 18, but I have to make this 6 be an 18. So what I'm going to do is I'm going to multiply it by something to make it be 18. Well, I'm going to multiply it by 3. But the only thing I can really multiply by without changing the whole problem up is 1. If you multiply by 1, it doesn't change it. It's going to stay the same. So I'm going to write 1 as 3/3. So now all I'm doing is I'm taking this 5/6 times 1. I'm just writing it as 3/3. And what that gains me, when we multiply fractions, you can just multiply the numerators and multiply the denominators. So I end up with a 15/18 plus 6/18. Now you have a common denominator, so you do like we did previously. You write the denominator and go ahead and do the operation with the numerators. 15 plus 6 is 21. Now that's an improper fraction because the numerator is larger than the denominator, but we're going to leave it that way. Sometimes you can change that to a mixed fraction and say 18 goes into 21 one time with 3 left over. So you might write it like this, and then you could also reduce the 3/18. But I wanted to show you that, but we really don't use mixed fractions very often in algebra, so we will leave them in this form of this improper. Now, the one other thing that you always want to look to do is try to reduce the fraction, though, if it will reduce. And in this case, it does. You look at what will go into 21 and into 18. And they both could be divided by 3. So what you do is you basically are going to divide the numerator by 3 and you're dividing the denominator by 3. It's kind of like what we did earlier when we multiplied by 3/3. Now we're dividing by 3/3. All right. Final answer then would be 7/6. Okay, let's try another. All right, on this next example, I don't have a common denominator, so I find what do 4 and 5 both go into. The answer would be 20, so I need them to both be 20. So I'm going to take the 4 times a 5, but I have to do it on the numerator as well. And over here on the right, I'm going to take the 5 times a 4, and that's how I'll get that to be 20. So then changing these fractions, they become 10/20 plus 12/20. Now these fractions are equivalent, but I just built this one up to have the common denominator. So add your numerators, that's 22/20. And then your last step, you look to try to reduce, see if anything goes into those. Well, they're both even numbers, so I know they both at least could divide by 2. So a 22 divided by 2 and a 20 divided by 2. So that would reduce to 11/10. Okay, let's try some weird ones here, like on this next one. This is strange because the first number is not a fraction. So anytime you get that, you immediately put it over 1 so that it looks like it's a fraction. So now you look to get a common denominator with these two. So I have a 1 and a 9. So they both go into 9. I won't have to change this fraction, but this one has to get multiplied by 9. And I'm going to do it on the top also. So that really is the equivalent of 45/9 minus 2/9. Do the operation on the numerators, 43, the denominator stays the same. And then you look to reduce, but I don't think anything goes into 43, so we're going to call that good right there. Okay, so what happens when we now have three fractions? Okay, that just means that you have to find a common denominator with all three of these denominators. And so looking at those three numbers and figuring out what goes into all of them, I believe the common denominator will be 60. So that means I'm going to have to take my 10 times 6, but also on the top. I'm going to take 12 times 5 and the 6 times 10. All right, so when I multiply those, I'll have a 60 for a denominator, and multiply the numerators gets me 18. Minus, let's do it again on the second fraction, and I'm going to have a 5, and then a minus, again on the third fraction, multiply, I just get a 10. All right, so since I have the common denominator, I can go ahead and combine these together, and I'm just going to work with my numerators. I'm going to take 18 minus 5, that's 13, minus 10, that's 3. So then I end up with 3 over 60. And then as far as looking to reduce, I do believe 3 will go into both of these, so I'm going to divide them both by 3, and that ends up getting me a 1 over 20 for a final reduced answer. All right, let's try one over here that has three fractions, but it also has a variable in it. Okay, that adds a little kink to our problem. So let's look at the denominators first, though. We've got a 6, a 3, and a 2, and we have to find out what goes in, or what those all go into. It would just be a 6. So let's make them all equal 6. The first one I don't have to do anything with, but the next one is going to be times 2, and the last one times a 3. So then I'll have a 4 over 6 minus, and what I'm doing is just multiplying this x times this 2. So x times 2 is really just written 2x. Minus, and then the last one's going to be a 27 over 6. All right, so we've got our common denominator of 6, and in the numerator, this 2x doesn't really get to add or subtract to a 4 or to a 27, not when you have the x attached to it. So you have to combine your like terms. That's going to be the 4 and the negative 27. That minus sign makes that 27 negative. And I'm going to leave my negative 20, or my negative 2x separate from those. And in fact, I'll probably write that one first. I'm going to write the negative from the subtraction sign, 2x. And then if I take a 4 minus 27, that gets me a negative 23. And then if I look at that to try to reduce or something, I can't. 23 isn't going to reduce with anything. So I'm done. There it is. All right, let's try one more of those. All right, on this problem, we have our variable tucked into the denominator. And that's going to mean that we have to use that variable as part of our common denominator. So when you're looking at what do 6 and n both go into, that's kind of a weird thought. So typically what we're going to do is we're just going to take the 6 times the n, but do it on the top also. That way it'll have an n in its denominator, just like this one has an n in its denominator. And likewise, we're going to take this one times 6, so it'll have a 6 just like this one has a 6. So take this times 6 over 6. And same thing with this last fraction, it'll need a 6 over 6. All right, so what we end up with then, 5 times n, we just call that 5n over 6n, plus, now I have a 4 times 6, that's 24, over n times 6, which I'm just going to switch around to 6n, so it looks like the other, plus, then I have a 36 over another n times 6, or 6n. So we have our common denominator of 6n, and we combine what we can and leave alone what we can't. So like on this 5n, there are no other n's on the top, so I'm just going to write 5n. And then these two numbers can be combined. It's a positive 24 and a positive 36, so that's going to add up to 60. All right, and then we do look to reduce, but the thing with reducing is, since this entire numerator is being divided by 6n, anything that I reduce is going to have to work on both of these terms. So for instance, like this n and this n, I can't reduce those because I don't have an n over here to reduce it with as well. Or like this 6 and 60 might be tempting to try to reduce that, but that only works if you can also reduce the 5. And you can't. So there's no reducing here. We're done. All right, hope this helps you out.